Everybody hear me? Cool. So Yannick and I have split up the time. I'm going to talk for half of this, then he's going to come up and talk. The first part of the talk is going to be about Lucene roadmap. I'm going to talk about history, what's going on in Lucene now, and some of the work that's happening that will be in future releases of Lucene. And then after that, I want to share the results of a survey that LucidWorks conducted over the last couple of weeks about solar developer and user experiences. So here's some Lucene and solar history and statistics. In '97, Doug Cutting created Lucene. He conceived of it as a commercial venture, essentially, but after a couple of years decided he didn't want to do that, and threw it up on SourceForge, where it got some attention and stayed for a couple of years, attracted a couple of committers. And in 2001, it found a new home at the Apache Software Foundation, where it still resides. In 2006, flexible indexing, a way to be able to plug in different index formats without having to massively recode the entirety of the code base. Discussions about that started in 2006, and those didn't come into fruition until Lucene 4.0. We see there 6 years later, so this is a really long-term project that the committers undertook. In 2007, Solar graduated from the Apache incubator and joined the Lucene PMC as a sub-project. 2008, flexible indexing implementation begins, so there was a lag there between talking about it and actually doing it, which is, I guess, not all that surprising. In 2010, there were a series of discussions about merging the development of the Lucene and solar projects. Because these were separate sets of committers and separate code bases, solar was depending upon defined releases of Lucene, so it lagged behind it. And there were problems with permissions and overlap and code that was being repeated multiple places. And the committers eventually decided that it just made a lot more sense for these two projects to become one for development purposes. And that happened in 2010. It took about a year for that to work out to a process that was repeatable. In 2011, Lucene and Solar 3.1 and all further releases were coordinated. And since then, there's been a total of 13 joint releases that have been produced. And in 2012, in October, Lucene and Solar 4.0 were released. This graph down here on the bottom left is a set of about 8, I call them milestone releases, but essentially important releases for various reasons of Lucene. The first one there on the left in March 2000 was the first release on SourceForge, 0.01. And believe it or not, you can actually go to SourceForge and download it yourself. I counted using a project that I got from SourceForge called CLOC, Count Lines of Code, the number of lines of code that were in the code base at each one of these releases. And in 0.01, there was only 7,000 lines of code. And you can see that 4.3, Lucene and Solar 4.3 are in the process of being vetted at this point and should be released within the next week. But that's stable at this point, and we've been over 500,000 lines of code for about a year now, roughly. You can see the growth there probably corresponds to growth in committers as well. So lots of work gone into this project. By the way, in case anybody cares, the lines of code I counted comments and code, but not blank lines. Those are the 3 categories that CLOC project produces. This graph on the right is about one of the things that people were frustrated in and led in part to the merging of Lucene and Solar, which is that it seemed like there were lots of things getting in the way of performing releases. They were just too hard. So both projects have been endeavoring and working toward quicker release cycles. So you can see that the average release interval in the 1.x release series was 16 months, down to 8 months in 2.x, just over 5 months in 3.x, and now and I'm including 4.3 in this average. Just over 2 months between each release. And I think the committers target something like 4 to 12 weeks as the interval that's ideal in terms of getting enough features and not delaying too long before those features get out to people who need them. So I'm going to describe some of the highlights of Lucene 4.0. I know that there are some people who still are on older versions of Lucene and Solar, so we'll probably find this interesting. Firstly, and probably the headline change in 4.0 was flexible indexing. These are also referred to as codecs, or bundles or suites of index formats. This allows people to, without having to rejigger the entire code base, experiment with alternative mechanisms for writing out and representing in memory the index. And this has been really successful for the project. Second, flexible scoring, which results in more index statistics and similarities that use them. So up until 4.0, Lucene only was capable of using the TF-IDF scoring formula that it had been using since its inception. But now you can just choose by configuration to use BM25 or language modeling or divergence from randomness or a couple of other built-in similarities, or build your own. Concurrent flushing was another really important change in 4.0 because it eliminated the bottleneck. A single thread was only allowed to flush at one time. That's also referred to as DWPT, or documents writer per thread. Doc values is another feature that was long in coming. This is sometimes referred to as column stride fields, or CSF. These are typed single-valued fields. More about that later. There's in 4.2 was a change made to have a kind of doc value that can have multiple values. But anyway, these are useful for flexible sorting and scoring. And norms, which previously were their own special format, are now stored as doc values. And one of the side benefits of that is that instead of being limited to the 8-bit float that norms had been up until 4.0, you can use any of the types that doc values support. There aren't any inbuilt formats that use larger than 8-bit norms that I'm aware of at this point, but so there would be some codec development required to do this, but it's now possible without huge effort. More RAM-efficient data structures, for example, terms, dictionary index, and field cache. Faster search filtering. Merge I/O can be rate limited to reduce I/O contention. Index reader is now per segment, which eliminates some of the inefficiency of having to always maintain a merged view of for example, the terms index over all of the readers over the segments in the index. And spatial search has been completely reworked. So I've put together Lucene 4.1 and 4.2 highlights because I wanted to refer to 4.0 as a unit, and 4.3, which has yet to be released, as its own thing. In between are these two releases. So I've mixed together their features. Seeks on writing out index files have been eliminated, and so what previously needed to be separate support for example, HDFS, which doesn't allow for seeking on writing, not to have to be separately supported. Stored fields are now by default compressed, which means that, of course, that the on-disk size has been reduced for that. Term vectors also are now compressed. There are two new suggesters, analyzing suggester and fuzzy suggester, which allow you to return suggestions which are not the same as the terms that are used, that are fed in to perform the suggestion. So you can perform analysis on input, but not return the analyzed form, instead return the surface form, for example. Fuzzy Suggester builds on that by allowing for inexact matches. Lucene has its own facet module that's at this point not integrated into Solar. And it's been seeing quite a bit of development over the last couple of releases. So some of the improvements in 4.1 and 4.2 are speed-ups, near real-time support, and a feature called Drill Sideways, which allows for faceting on neighboring facets after you drill down, going to alternatives or additional facets without having to go back up again. Postings Highlighter is a new highlighter that uses posting offsets in order to perform highlighting against stored fields, for example. It also can, as of I think 4.2 or 4.3, I forget, can highlight from other sources besides stored fields. Common terms query speeds up queries that have highly frequent terms, which can be very slow, by rewriting the query to handle that elegantly. And the doc values API was essentially rewritten to have a simpler API and improve its performance and its RAM consumption as well. The FST package, which is used for various places in Lucene, including the terms dictionary, by default anyway, now supports FSTs that are over 2 gigabytes in size. So if you've got a huge terms dictionary, that's now supportable. And the feature that Solar calls real-time get is now available in Lucene via this class called live field values. There's a new classification module that's actually been on trunk for a while. That was just backported to 4.2 that allows for you to use already indexed values as a source of training that you then apply to new documents to add classification to them. So as I said, Lucene and also Solar 4.3 is in the process of being vetted and likely to be released in the next week or so. And here's some of its features. The Boolean queries, which include a min should match constraint, have been modified to use skipping to realize a major performance improvement. I think something like, and for some queries, 4,000% faster. There's a feature which was present in some version of 3.x, I forget which one exactly, that's been brought back in a non-static version to perform sorting on individual segments and also on the whole index via these two classes. There are several use cases for having sorted indexes, one of which is the ability to terminate queries early if you know that you've visited all of the elements of the index that you need to in order to satisfy a query. That's problematic for a multi-segment index. So in addition, I didn't write these down here, but in addition to these two classes, there's another class that allows for early termination per segment. And in that way, it should be possible, although I don't know if there are any examples of actually using it at this point since it's so new, to speed up certain kinds of searches. DocID set iterator or DISI and Scorer now have a cost API that can be used to optimize sequencing of operations for querying and filtering. Analyzing and fuzzy suggester now enable recording an arbitrary byte as payload, which can be returned. The spatial module now includes support for query relations within, contains, and disjoint in addition to the intersect a relation that it has had. And the facet module now has a new method that doesn't need a separate sidecar taxonomy index that can compute facet counts using a new kind of doc values field. So earlier I said about 4.0 that doc values were single valued, but there's a new form of doc values that can be multi-valued, this sorted set doc values field. And this method for the Lucene facet module uses that field in order to store taxonomies. So beyond 4.3, I'd like to be able to say that there's some grand vision for all of the things that everyone wants to do with Lucene, but as it turns out, the people who contribute to Lucene have lots of different goals and don't necessarily coordinate with one another. So what ends up happening is you get what people bring, right? So I went out and looked at JIRA to collect the ideas that are currently being worked on, and here are a few of them. So more efficient positional queries have been worked on for quite a while. If you follow any of the list, you might see this idea referred to as nuking spans. Span queries are a family of queries that can take into account positional information in order to return results. These things are hard to maintain because they touch lots of different parts of code. This current effort at more efficient positional queries also has the benefit of being able to be tacked on to any other query rather than having to be sort of be re-implemented and then add positioning information to it. Another long running effort is being able to perform incremental field updates. Solar recently got a feature to be able to perform a task like this. It's called atomic updates. And it does this by storing all the values for a document, or all the fields for a document, and then when you want to perform an update on a single field, Solar goes and retrieves all those other fields and analyzes them again and adds in the new field value or modification that you supply. The idea behind incremental field updates, though, is to allow for a facility that doesn't require reanalysis. And there are several different approaches under discussion, and it looks like only one of those is actually seeing much traction at this point. So maybe this will materialize sometime in the near future, hopefully. Recently, there have been two new code contributions that were developed outside of the Apache Software Foundation, which is fairly unusual for Lucene. One of these is for a Korean analyzer, which looks like a really nice resource, in part because Lucene doesn't have a Korean analyzer at this point. So I'm not sure how this will take Lucene as a project, but I think it's great that people think of Lucene as a good repository for their work that they've either developed specifically for Lucene or outside of it and want to bring it into Lucene. So hopefully we'll see more efforts like that. So the Korean analyzer is still in the process of being vetted for intellectual property, and it'll have to be folded into the code base, but it'll be great once that effort is complete. This was a survey that LucidWorks conducted over the last 2-3 weeks. The survey invitation was emailed to 4,136 people who were training class attendees, Revolution attendees, and LucidWorks webinar registrants. So far, 177. I imagine some of you were respondents. I'm going to be showing results for some of these questions, but not all of them. Here's, I think, one of the more interesting ones. The question was to rank the following features by priority. So essentially, what do you think is important in your use of Solar? So faceting, high-quality relevance, distributed indexing, and search are way up at the top. Good documentation, easy install, deployment configuration, Lucene as a search server, near real-time support. So all of these got a certain level of priority. So even though question answering was ranked below all the others, it's not at zero priority. So some people thought that was important. So on this question, how easy was it to install, deploy solar? It looks as though no one, or very few people thought that it was extremely easy, but I think it still fits comfortably within the range of not too hard. The solar interface, I suppose this must be referring to the admin GUI. And I also suspect that this, if everyone had been exposed to the 4.x admin GUI, that this would be shifted higher, given that pie chart that showed lots of people were still on 3.x. That, in my opinion anyway, the admin GUI is much more user-friendly now. The solar project documentation usefulness ranks pretty useful. Satisfaction with overall performance, that skews pretty high. I think this is interesting because for improving developer user experience, it's clear that people think more code samples and better documentation are the very much the highest priorities here. So hopefully we can be doing things to improve that situation. I had a couple more questions that I wanted to ask of the audience real quick here. Can I ask for a show of hands for people who are Eclipse developers? Wow, we got about 50%. And how many attendees are running Solar Cloud in production right now? Fewer than 50%. That looks like more like about 5 or 10%. And that was it for questions. And we're all done. Thank you very much for your time.